Hi everyone. In this video, we are going to solve day 6 problem, which is factorial of a number. Factorial of a number is nothing but is to decrease the each one of the number. For example, here it is the product of all the positive integers less than or equal to a given non-negative integer. So for example, 4 factorial is nothing but 4, 3, 2, 1 is equal to 24. By convention, factorial of 0 is nothing but it is a 1. So we can use in like such a number of applications like permutations and probability sequences, these types we can use the factorial. So for example, it can be multiply the number by every positive integer smaller than it to down to 1. So 3 factorial, 5 factorial. Mathematical notation will be like this. Special case is nothing but like a factorial of 0 is always 1. Right. So here it is given a small explanation that what is the factorial, which number before it, right? The all numbers before it until 1. Okay. So here the special case, which is nothing but the edge case also. Right, base condition also. Okay. So here we are going to solve that. Here giving ints by different approaches, recursive, iterative and built-in function. Okay. So let's try to through the iterative function. First start with this and multiply all numbers from 1 to n. Okay. Let's create a file. Day 4. Sorry, day 6. We have to find the factorial. Factorial, right, .py. So firstly, let's define a function factorial. In this, we have to import or we have to take a parameter argument number, right? So we have to iterate, right? Let's try to print first. Print of factorial of, let's say, as example says in ChatGPT 5, we have to get the output as 120, is it? So what here happens, we have to decrease or increase the number, right, from n, right? So for example, for I in range of n, then what we can do, we have to increase or decrease. Let's say 0 into anything is 0. So let's I thinking that from 1 to n. Next we have to multiply that, right? So as ChatGPT said, we have to define a variable is equal to 1. Why here 1 only? Why here not 0? 0 means it is really a, it will 0 will produce all the 0. So result is equal to result into 1, and we have to return that. Or we can simply say like a factorial for our ease. I think it is better for like simply not like a result. Okay, let's try to run this. No, it is only giving that 1. Okay, 1 to n. We have to plus 1. And what is the prop? Let's try to run this. No. Factorial of 1 and factorial is equal to factorial into, okay, here I have to say I. So let's try to run. Yes, answer I will get 120. Here I also changed the number n plus 1 because range will skips this number like a 1 to n only. N will skips. So I have also included like a 1, 2, 3, 4, 5. I also have included by increasing by 1. Okay. So recursive may be like this. Let's see how it's go. And base in this base conditional as this. Okay. Like for example, step by step approach. Take an input and create a variable. Run loop from 1 to n. Multiply each number with result, and final result will be like that. Yes, approach is like iterative, like same what we have did, same here, same that only. So it is just printing. That's great. Next, recursive approach will be different. We have to keep in mind when recursive is like a base condition, which is nothing but recursive means looping in that function only, right? We have to stop that function. So in that case we need the base condition. Here we only returning 1 because multiply of 1 will gives result, 0 will gives nothing, 0 only. So what is recursion, right? Recursion, let's say in Python. So recursion is nothing but it is also taking a sample of factorial only. Means it's a basic example for the recursive, right? So it is a Python programming technique which function calls itself during its execution. So it is like a, what we can say, it is like a, for example, uh, it's all executes, for example, checking. If the base condition is equal, then return 1, then it is executes this. Right? It is also saying, see, firstly, it is not directly executes all this one. Just checks 1 and it will return the function by in a backtrack way. Right? See, imagine solving a problem, making it smaller, and the function handles small parts of the problem. This continues until the problem is so small. It can be solved directly by the base case. Then results from these smaller problems are combined as a recursive calls return, eventually providing the solution to the original problem. Okay. Let's try to see some images if there, yes, see. For example, here, if we have, it just go in the way, go in the way, go in the way, go in the way. Here, where it will not execute. If it is in a backtrack, then it will execute like just going, see, it is trying to multiplying. So first it like goes like straight way and reverse way in the, like a backtrack. We can name it like a backtrack. Okay, let's try to see what is that. And the next approach is nothing but a built-in function like import math dot factorial is nothing but simple way. So multiplies numbers and this all. So here most important points for that edge cases, right? If n is equal to 0, then answer is 1. If n is equal to 1, answer is 1. These are the edge cases. So how we handle the edge cases if we have these numbers? Normally we not count how to solve these. That's directly taking these numbers. Okay. Negative numbers. If we get negative numbers, factorial is not defined. You can handle this by returning a message, not defined. Constraints are nothing but input should be non-negative integers. So constraint is nothing but how much the input, how many inputs we can take and how much range. So here input should be a non-negative, means it is a positive number. For large number, factorial grows extremely fast, big numbers. Okay. Time complexity is iterative, will take 0, big of n, means it's like a number of inputs is equal to number of outputs time. Okay, number of inputs is equal to time. It takes how much it will inputs, then output also same in that time only. Recursive also takes in that time. Built-in optimized internally. Space will take iterative like a 0 of 1. Recursive takes 0 of n stack calls, so it will take number of input times only. Just one variable. Okay, you don't confuse if you do if you don't know. Just have only the basic knowledge how that works. Time complexity and space complexity means anytime if the input, for example, if we have large number of array, like for example 1 2 like so much of array, then the input way the loop will runs, and input way the while loop will runs. No, it's like running the number of times of the number of inputs elements. Okay, so that's I mean only. We have to learn in this also. So okay, best for the interviews and assessment is like iterative. First we have it like so. It is the best for the interview. If they ask in recursive, then we have to implement in the recursive also. So approaches like this most. Yes, it is just I have given this explain with particular things. Okay, multiply numbers from 1 to n. Yes, it is just multiplying from the 1 to n. In the factorial we can observe that it multiplies in reverse way. Just see by minusing. 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1, like so much like a, if n is equal to 1 or n is equal to 0, then it directly returns, it executes. The base condition is over, so then it executes all this. Okay, let's try to do the iterative method with while loop. So here it directly given the base condition. So same as like that as we did, but here while loop. Let's try to run. Okay, while loop, first what he will divide if n is equal to 0 or n is equal to 1, then we have to return 1. Means it is directly saying, okay, it is like an edge case. Okay, if next while loop, right? Normally in that we have defined a factorial is equal to 1, right? Then we have to define while if n is greater than 1. Is it? Yes. Keep multiplying until n becomes 1. Means here decreasing here. Okay, means factorial is equal to factorial into n. Means same as like a recursion, but in the way of using while loop. Okay, we have to decrease the n. So let's say it is 5, right? 5 is greater than 1. Yes, so the loop enters 5 into factorial. Then it becomes n becomes 4. Next 4 is greater than 1. Yes, so 4 into 5, because already we did the 5. 4 into 5 is nothing but 4 20. So then it's also did the decrease the 4 minus 1 3. So all doing that multiplying 4 like a 5 into 4 into 3 into 1. So if it is 1 is greater than 1, no, so then loop is executes. So by just return factorial number, right? Let's try to run this. Yes, we get that. Next by using recursion, right? recursion. Let's try to comment this and this also. Okay, if we give the answer like 0, then it automatically takes that one. Okay. Recursion, the base condition is nothing but like n is equal to 0 or n is equal to 1. Then we have to return what? None, 1. So in that, for, is it for? No, no, no. I think recursion part will take a different way. I'm also like that. Recursion function is like this using the definition. So the base case is like a stop recursion here. The recursive case is the function was itself is this. Okay, the base to stop. Okay, the function keeps calling itself with the smaller values until it hits the base. It is decreasing the value. So simple and elegant, but large and recursion depth can be problem. Okay, if we have the large numbers, it can be problem. So let's try to return n into factorial of n minus 1. So here we not define n. Sorry. Here we have to give the function, right? See, if 5, right? 5 is equal to 0 or 1? No. So 5 into factorial of n minus 1 means 4. So it again goes to function. Then 4 into n minus 1 is 3. Again goes to here. 3 into n minus 1 is again goes here. Like for example, we did here, right? 2 into 1. No, 5 into, sorry, here reverse calling, right? So 1 into 2. First time will be like this, 3 into 3 and 3 into 2 factorial, right? It's like a 5 into 4, 4 into 3, 3 factorial, like a 3 into 2 factorial, 2 into 1. So it is like if it is executes like here, n is 1. N is 1, then returns 1. Then it executes 1 into 2, then 2. Then goes here 3 into 2, 6. Goes here like a 3 factorial is nothing but 6. Here like that same way here we get the 120 factorial. Okay, we can also observe debugging. Let's see. Okay, what is the next? It's loading. Next, using the built-in function just by importing math.factorial of 5. It's a simple. We import math module like Python standard library, call, and fast, reliable, but in interviews they prefer manual logic. Okay. So using reduce also, functional programming style uses func tools to reduce to multiply all numbers. Return reduce takes a function and sequence, same as like a filter, as we did like a filter of anything, right? So here multiply all numbers from 1 to n, and what is this? Reduce function is also, I'm also new to this topic. So yes, it is also same as like a filter function reduce. So here we can import reduce from the func tools, right? Yes, next print that output will be like this. Here taking the function as x into y, right? X into y, and range will be like a 1 to n, like a 1 into 2, 2 into 3, 3 into 4, like that. I think so. Just increasing by 1, I think, step, right? Keep applying a function on the list. We use lambda function for the multiplication, and this shows the Python knowledge but less reliable for the beginners. Yes, of course. Using math.plot. which is nothing but like a newer version to direct product function. Okay, math dot product gives the takes the range. If n is greater than 0, it is not 1. Multiplies everything in the range, similar to the reduce but cleaner. Okay, let's see. It is a, yes, it is get. Try to observe here only. Let's try to go. Okay, here n is 5. I think it goes not. Yes, it is. See there. See, let's try to stop here and try to stick here. I think that it will be clear to see how it's going. Yes, so first it goes here. So here calling function, right? We can also observe here the backtracking also. If n is equal to 0, no, it will not. Then returns the function. Yes, returns the function. If n is equal to 5, then n factorial of n minus 1 is 4. Observe here. Yes, it's a 4. Then here calling the each time functioning, right? Calling function, and next see, observe that like number of times it is calling from 1. It is 1, right? Then returns 1. Then here backtrack will be goes here having filling all the values in the stack. Then it is returning factorial 1 to 1 in factorial 2, returning C. It is going also here. Next it will print the function. Yes, so in this way we are do the debug if have any doubts. Okay, yes, so here the summary approaches is like nothing but best for the interviews, and while loop is like a same but different style. Okay, recursive is like elegant but risky for the large numbers. We have to keep in, but the recursive is a risk for the large numbers. If in the interview they will may ask. Built in best for the projects, not in interviews. Okay, functional, compact, advanced but less for the beginners, and clean and modern. Okay, it's like a prod, right? Just taking return math dot prod of any range if it is greater than, right? Okay, edge cases are nothing but is this all manual methods n times. Okay, n is nothing but the input 5, right? In the range we taking, range means it in the type of a list, right? Okay, this covers all the approaches in the all this way. So okay, next day 7, so that we can observe that you can prepare day 7 problem also. It is again giving factorial of a number. Is it? Yes, it is again giving factorial of the number. Day 7 challenge. Okay, some of the elements in the list we have to see in the next video. Thank you for all. In next video we are going to solve this problem. We will catch up. Thank you.